Start recording. Okay, this is our Wednesday lecture review over pharmaceutics. Joe and I are going to try and go through it and make it more understandable for anybody who has a question on anything we went through. I think where we started on Wednesday, didn't he start on the molar heat capacity?
I was it that it was either that or Hess's law.
Yeah, I think it, but the molar heat capacity, he did a example of it, but basically when we're talking about the molar heat capacity, it's this equation right here. It's the C equals Q over dt. And I kind of wrote out a way on how he solved this over here in case this confused anybody right here. Oops. But basically we start out with 4,000 calories over a 5-degree temp increase for 4 moles. But what we want is up here is 1 mole by 1 degree. So to get this 4,000 calories into 1 degree, I divide it by the 5. So now I have 800 calories per 1 degree, but I still have 4 moles. So to get to that, I have to divide 800 by 4, and I get to my 200 calories per 1 degree per 1 mole, and that would be my Q per dt up here. So that is what your molar heat capacity would equal. Do you agree with that, Joe, on how I worked that out?
I do, and I actually missed that. So good thing that I
For us at all. He just on the PowerPoint, he just had something similar to this typed up there, and I can't read an equation written like that and understand it. I have to go over to the side and work it out for myself, so that's what I did. So those are pretty easy. If you just remember, like, no matter what they give us for calories and degrees and moles, you just have to figure out how many degree changes there were, which here was 5, and you have to get it all down to 1. So just start dividing until you get to 1 degree Celsius and 1 mole, and that would be your heat capacity.
Mhm.
So that was one thing that he went over. And if anybody wants to do an example later, I'm sure I can find some online so somebody can just text me or Facebook me or something. And then the next thing that was in our, this is the quiz review that I'm looking at, by the way. The next thing that was in there was a question over, oh my, everything's shifted for some reason. On here, my words are written over. I don't know what I did on this. The question though is, if a chemical reaction releases heat, it's called a, and the answer is exothermic. And I had made notes next to each one, but everything shifted for some reason. And so an endothermic reaction is heat absorbed. Where's my pen at? I lose that thing every time. Oh, I don't have a stylus right now, but I was going to move everything. But an endothermic reaction is when you absorb heat. So basically, if you're doing something in a beaker, it would get cold because it's absorbing the heat. And an exothermic reaction is releasing heat. So if you were to touch the beaker, it would be hot. When he was talking about negative calories and positive calories, an endothermic reaction will be positive and the exothermic will be negative. And a way you can remember that is the reason exothermic reactions are negative is because they're getting rid of heat. So you are subtracting heat. An endothermic reaction will be positive because it is gaining heat. You are adding heat. So if that helps anybody remember the differences in that, hopefully that helps. Gosh, I can't read these. How did I move this down? These are some other questions. If I can read it. Heat of formation of carbon dioxide is negative 95, does that say 52 calories where the negative sign signifies that? And we just talked about this where it was, since it's negative, the formation of carbon dioxide is an exothermic reaction. So, and then I also wrote in notes here that heat involved in the formation of a compound from its elements is what a heat of formation is, and negative calories is exothermic, positive is endo. And I made an example around here somewhere. Oh, here it is, of how he was talking about the heat of formation is the same no matter how you get there. And he used carbon dioxide as an example, and I noticed on his PowerPoint that he had this part down here backwards compared to how I learned it, so I flipped it around. So this equation will be opposite in his notes that he's made. But here he just wants to prove that going from ingredients to a product, it doesn't matter how many steps you take to get there, you're always going to have the same, oh, what is that called? What is that called, Joe?
formation.
Oh yeah, the same formation. All my words run together. So I kind of wrote it out here for you guys. If you add carbon with two oxygen to get CO2, your total is negative 94.052, and that means that it's exothermic because it's negative. If we were to look at this equation going stepwise, the first step is going with a carbon and one oxygen molecule since you have half of an O2. That takes you to CO. So that's A to B. And when you went from A to B, this is the energy, the heat that it released right here. So now we have CO, but we want to get to CO2. So you would add another half of O2, which would be one oxygen molecule, and that would get you from B to C. And going from B to C released this much heat right here, the 67.636. And when you add those together, you get the same answer as when you just went straight from A to C. So just pointing that out, like if in case anybody was confused with the fact that the heat of formation is the same no matter how many steps or how little steps you take, as long as the equation isn't different. Do you agree on all of that? Okay, and then here's another example that I made just using letters. A to F would be X kilocalories, but if I went through each step, I would add each little one together to get X, and X equals X no matter which way. That was breaking it down. Moving on to Hess's law. Oh, that's what I was just talking about was Hess's law, I guess. Constant heat of summation states that the heat released or absorbed in a chemical process is the same, whether the process takes place in one or several steps. And then like I've explained already, if there are several steps, you just add them all together. And then he didn't talk too much on these ones, but I just threw in some stuff there so that when I'm studying through, it might help you guys. One way I got this picture over here, where's my mouse at? Oh, there it is. One way I got this picture is I just went to the PowerPoint and I used our little scissors that we had available to us, and I cut it out and I copied it to clipboard and then I pasted it over here. So if you guys forgot how to do that, just I can show you how to do that too, but that's one way to get everything all in one spot. And then I type all my notes in red too. We haven't really got too far into this. I think he's going to go over it again on Friday. Is there anything you think I missed, Joe, to review people on?
Let me see.
We can present it from your computer if you find something that you think is important for them to know, to study. Oh, one other thing I was going to show you guys. Sorry, Joe. Was I have this Study Blue account that I use. It's similar to Quizlet, and I have been adding flashcards. Not that I'm trying to like just straight up memorize all this stuff, but when I'm in this, I can go to my top 3 quiz 3 that I've created, and I can click on a review sheet, and I can go to all terms, random, it doesn't really matter. I'm going to do them in order because it follows the class. And it kind of gives me like a breakdown of what I think I need to know, and I can just scroll through it. And I have this app on my phone also, so when I go to lay down in bed at like 11 o'clock, I just sit here and scroll through stuff on my Study Blue until about midnight to kind of give myself one last review before I go to sleep. So if anybody is interested in how to do this, I can help you do that. And I can also share my flashcards with you, but I think you have to purchase a membership, which it isn't that much. I think it's like $40 for like the whole year. And then you can view my flashcards. And I know Kathy Bauer is using this as well, so she has flashcards on here if anybody is interested. But I've kind of just went through and made questions that I think would be on the quiz. Like here's one, like if the calories are positive in a reaction, then it is said to be, and then when you'd flip it, it'd say endothermic if you were using note cards. So, but anything else, Joe?
Here.
No? All right, well, I think that just concludes our quick review for the day. So hopefully this helps people. If you have any questions, just
The only other thing that we should probably go over is the uh, delta G, because you had that question about that concentration.
the con I think I was writing about it over here in Word. He started to go over this delta G stuff, and I haven't had a chance to like actually get online and read about it because I've been using online resources because there isn't too much to read on in our book. If anybody's tried to look up thermodynamics in our book, it's like a whole 2 pages, and then the equations are even different from what he's teaching us. So I don't recommend the book. Um, if you want to explain that, Joe, that'd probably be better. Do you want to switch to your screen?
Sure.
Okay.
So,
'Cause you seem to have a better understanding on that than I did. So I'm gonna stop presenting.
mm, do you see my monitor?
Yep, it just popped up on your fancy little notes page here. Oh, look at that. How do you make it look like a piece of paper? You should tell me that after we're done with this.
Um, so this was after we went over the third law of thermodynamics, which is essentially the entropy of a pure substance would be zero at absolute temperature or absolute zero temperature, meaning there's no randomness. You hear me all right?
Mm-hmm.
Okay. Um, the delta G equation or the Gibbs free energy equation, which is uh, shown, let me get my pointer, shown here and down here as an actual problem being worked out.
Oh, cool.
The only thing that's important is to remember is that when you're talking about concentration 1 and concentration 2, concentration 1 is always where it's coming from. So on this question, it's asking you to calculate if a um, zero point zero 0.01 moles of urea transferring from plasma to urine is spontaneous. So in your equation over here would be the natural log of 0.006, which is given right here, over the natural log of 0.345, which is given right here. So the concentration is 0.006 for urea, which is where it's coming from. I think I wrote it down wrong. This is the right way to go. And then where it's going to, so the answer after you plug everything in, and you have to know which R value to use, which it's looking like most of the R values that we'll ever use is 1.987. I know a lot of people in Gen Chem 2 use the 0.08421.
2-1. Mm-hmm.
But since this comes out to be a positive number, 25 calories, it will not be spontaneous, which I think in the example he used, it would just be you would use internal energy, which would be ATP, to make this reaction go, since it's
Yeah, so
greater than zero.
we'd have to do something like apply heat or something to make that move
Yeah,
from left to right in the reaction.
yeah. But in our body, I think you would use some sort of an ATP
Oh,
energy, but
true.
that's
Yeah, because we're
that's
thinking
beyond where we're at right now.
biochem right now. Yeah.
Yeah. So
And if it was less than
um,
zero, then it would just
if it was
happen
less than
spontaneous.
zero, it would happen spontaneously. This is another um, example. Sorry for the chicken scratch. So it's HCl in your stomach is 0.135. In your blood, it's 5.18 times 10 to the negative 8. So it's asking you if it goes from your blood to your stomach, um, will it be spontaneous? And after you plug everything in, you do natural log of 5.18 times 10 to the negative 8 over 0.135. Since it's going from blood to stomach, you get an answer of like 14,000 calories, which obviously is greater than zero, so it would not be spontaneous. So there would be some sort of process or mechanism that would create that.
Okay, and a question like I guess I had just finished watching this lecture, so I'm kind of a little confused. Are we ever actually going to use the simpler versions of the equations, like the delta G equals delta T minus T delta S, or the other?
I don't think so.
We're just going to use the one that has the nRT and the concentration 1 and concentration 2.
Yeah, because the delta G that's on here on our test exam formula sheet is the
Hmm.
delta G equals nRT times natural log of C2 over C1.
Oh, okay, so yeah, it doesn't look like we'll ever use the other two. That's where I was getting confused as to why he wasn't using the other two, but I was going to read into it. So it looks like it just, as long
Um,
as he gives us two concentrations, it looks like we'll know which one to use.
and this might actually be wrong. This might need to be um, because after I was thinking about it, HCl should go from blood to your stomach fairly easily because it's going from your blood to stomach, so it's coming. See, so this would be
So from the blood would be
C1. This is
C1,
C2.
and C2 is your stomach because that's where it's going to. Okay.
Yeah. So then I flip-flop this. So this would probably be negative, so it probably would happen spontaneously. I don't have a calculator on me, so I can't do that as fast as, but flipping that would probably flip the sign.
Yeah.
So
All
that's
right. Well,
that. No.
and we'll work over that. Was this an example out of the notes?
I think it was an example out of the Word document.
Okay, the Word document. All right, I'll look it up then,
Yeah.
and I'll use this at the end of this video to see if I reach a negative answer similar to yours.
Yeah. So back to making this look like a notepad.
Mm-hmm.
A notepad. If you go to um, you go to View,
Mm-hmm.
rule lines, and you can add however thick you want.
Oh,
And then
okay.
and then you can change your page color to whichever one you want. I've always heard legal is bad, guys. I don't know if that's true for computer screens, but if you go to options and if you go to advanced, uh, no, display, create all new pages with rule lines, so you won't have to continually go add rule lines.
Mm-hmm.
So yeah,
I like that. All right, cool. I don't know if I'll use it or not yet because I tend to scribble all over my slides as of right now.
I do that
Alrighty.
also, but I always figured it's easier to read straight than up and down.
Yep. All right, well,
So
I'm going to stop the recording. That's all for today. If anybody has questions, it seems like Joe has a pretty good understanding of that end part, so I would message him if I were y'all. So, sorry, Joe, but I just volunteered you for a whole bunch of stuff.
that's cool. Hey, did you do the flashcards for calculation?
Sure did. So if you get a thing on, if anybody gets a deal on Study Blue, let me know and I will send you an email invite. I have flashcards in almost every class just to help me out. I paid for the pro version, meaning that I can put pictures on my flashcards. So today I'm going to be making flashcards that have the protein structures on it. So if anybody wants to get in on that, I think to view my cards, you can view parts of them for free, but to view my all of my decks, you have to pay for it, which it kind of sucks. But I've used Study Blue like my whole life. I've never really used Quizlet. I don't know if Quizlet has picture options. If so, somebody holler at me, and I'll probably start using that next year once my membership's up.
Uh, I don't know
So
if it does on the upgraded. I don't think it does in the free version.
yeah, so I think no matter which one we use, we have to. And I mean, Study Blue has almost the same stuff as Quizlet. I mean, it'll do multiple choice questions for you. It won't do games, but it'll do true or false, multiple choice, so whichever you want to work on. So they all help. And like I said, I use the app on my phone all the time. So like when I'm driving up to Wichita, which is an hour away from me, I hand my phone to my boyfriend and I tell him to read me stuff. Or if he's driving, I'm pretty much on my phone all the way up there and I'm on Study Blue studying. So it's an easy way to carry a million note cards without actually carrying a million note cards. So, all right,
Yeah.
guys. I'm keep saying I'm gonna stop recording and I haven't, so I'm stopping now.